Welcome to the Explainer. I am absolutely thrilled to have you here today because, we're gonna tear down the walls of the internet to see what actually makes it tick. We are leaving all those ancient 10-year-old dead exploits behind. Seriously, forget the old SQL injection garbage of the past. Today, we are looking exclusively at real modern 2026 web hacking techniques. We are gonna look at the exact architecture of a modern exploit layer by layer, but before we look at a single vulnerability, we really need to establish rule number one of hacking. You cannot break what you do not understand. I say this with absolute conviction. If you don't know how a developer built the wall, you are never gonna know where they forgot to pour the cement. It's really that simple. You have to understand the architecture first because there's just a massive difference in how people approach this. Script kiddies, they kinda think hacking is just throwing an automated scanner at a login page, crossing their fingers, and waiting for some magic password to drop. But real hackers, they actually spend 90% of their time on reconnaissance and architecture mapping. Let me share this incredible story from our source material. So, this hacker was targeting a massive financial company. Now, their main website was an absolute fortress, firewalls, the whole shebang. But because he understood architecture, he didn't even bother attacking the main site. He spent 2 whole weeks just doing recon, mapping subdomains, APIs, DNS records. And you know what he found? A forgotten development server from 3 years ago, just sitting on a weird subdomain with zero firewall, one payload later, and he had the entire network. Okay, let's dive into this. Here is our roadmap to systematically dismantle the layers of modern web architecture, DNS and subdomains, intercepting APIs, cloud servers, NoSQL databases, and finally, forging sessions. Section 1, DNS and subdomain takeovers, the front door. To really get this, think of the domain name, system, DNS as a massive public phone book. It just translates a name like google.com into IP numbers. So how do you hack that? Well, hackers don't attack the IP address. They go after the phone book itself. Imagine a huge company launches a customer support portal. They create a subdomain, say support.company.com, and they point that DNS record to a third party cloud service like Zendesk. Fast forward 2 years. The company closes the portal, they cancel the Zendesk account, but some lazy IT guy completely forgets to delete the actual DNS record in the phone book. Step 1, a hacker scans and finds that dead record. Step 2, the hacker simply goes to Zendesk, pays $10, and registers a brand new account claiming that exact name. And just like that, step 3, they have full control of a trusted, verified company subdomain. The company's own phone book is literally routing millions of trusted users straight into the hacker's phishing scam. Crazy, right? So they've bypassed the front door, but that begs the question, where does the real magic happen after the browser actually loads the page? Section 2, Intercepting APIs with BOLA, the hidden logic. In 2026, websites aren't just static pages anymore, they are incredibly complex applications. While normal folks just see pretty buttons on a screen, the browser is actually firing off invisible API requests in the background to fetch raw data. And this is exactly where a devastating vulnerability called BOLA comes into play, broken object level authorization. This happens when a backend developer is just lazy with their security checks. Hackers use an intercepting proxy tool like Perp Suite to catch these invisible API requests in midair. It's literally like freezing the internet in time before the request ever reaches the server. Now, what's really interesting here is how simple the manipulation is. Look at the original request. The user's ID is 1045. The server is about to send back user 1045's private receipt, but while time is frozen, the hacker just clicks that number, deletes the 5, and types A6. They forward that manipulated request. The server checks if the users logged in, which they are, but completely forgets to check if they actually have authorization to view user 1046's data. Suddenly, boom, the server hands over a total stranger's home address and credit card info. But wait, modern hackers go even deeper than just changing ID numbers. By attacking the logic itself, They can change the actual command being sent in the dark. If they intercept a request and just change the command word from get to delete, they can completely wipe out another user's entire account with a single keystroke. No way, right? Just one word. Section 3, Cloud Servers and SSRF Hacking the Brain. Let's push even deeper into the architecture, right to the server itself. This is the brain that runs the code. Today in 2026, 99% of servers are hosted in the cloud, places like Amazon Web Services, Google Cloud, or Azure. And the exploit of choice here, SSRF, or server-side request forgery. This is absolutely one of the most devastating attacks in modern cloud computing. Instead of trying to smash through a firewall from the outside, the hacker forces the web server to blindly visit internal private network addresses on their behalf. The firewall already trusts the server, so you are effectively forcing the server to hack itself. So picture a feature where you can submit a link to upload a profile picture. The server is supposed to go fetch that picture, but instead of a picture link, the hacker injects Amazon's secret magic cloud metadata IP address. It's an address built into every single cloud server. The server blindly visits this address, and because it's an Amazon instance, it answers the request by just dumping its own private master access keys right into the hacker's terminal. I mean, think about that. No passwords guessed, no firewalls broken. They just asked a secret endpoint a question, and the server handed over the keys to the entire cloud infrastructure. So behind that server sits the vault, the database storing all the passwords, emails, and credit cards. But if old hackers used SQL injection and modern startups today use completely different technologies, can we still inject the database? Section 4, cracking the NoSQL vault, mathematical logic. The answer is an absolute undeniable yes. Today's startups use NoSQL databases like MongoDB where there is zero SQL language. It's entirely made up of data objects, but the logic, it can absolutely still be broken. Instead of typing a password, the hacker intercepts the login request. In a normal login, it's expecting an exact password string. But for a NoSQL injection, the hacker deletes their password entirely and injects a mathematical operator that literally translates to not equal to nothing. They're basically telling the database to log them into the admin account as long as the password is not empty. And since the real admin password obviously isn't empty, that mathematical statement evaluates to true. The database vault swings wide open, granting instant admin access, and the hacker never even knew the actual password. Section 5, forging VIP session tokens, the end user pass. Think of sessions as the digital VIP wristbands of the internet. You see, the internet inherently has no memory. It's completely amnesiac. Every single time you click a link, the server forgets who you are. So to fix this, when you log in, the server hands your browser a session token, so you don't have to keep logging in on every single page. In modern apps, these wristbands are usually JWTs or JSON Web Tokens. If you intercept one of these, to you and me, it looks like a massive string of pure gibberish. But to a hacker, the first three letters of a JWT are a dead giveaway that the data isn't encrypted at all. It's just encoded, meaning it's totally readable. Now, to stop people from just rewriting their own permissions, the server signs the very end of the token with a secret cryptographic signature. But let's be real, humans are lazy. Developers sometimes use really weak secret keys. So the hacker decodes the token and reads their data. It says role customer. If they change it to admin right then and there, the signature breaks and they get rejected. So instead, they extract that cryptographic signature, load it into a cracking tool, and use a massive graphics card to run millions of computations a second to brute force the server's secret key. If the developer used something weak like secret 123, the computer cracks it in an instant. The hacker then changes the role to admin and uses that crack key to mathematically forge a brand new perfectly valid signature. They have essentially printed their own VIP wristband that grants them literal god mode access. Take a step back and just look at what we've covered today. DNS, API requests, cloud metadata, databases, and sessions. Normal folks log on to a website and they just see a pretty button to click. But by understanding these layers, You now see the matrix, you can see the hidden logic, the flow of the data, and exactly where the weak points exist in modern web architecture. I'll leave you with this provocative thought. If you don't understand how the car engine works, can you ever really be a mechanic? The exact same goes for the web. You can't just be a script kiddie throwing old dead payloads from a 10-year-old forum. You have to build your foundation and truly understand the architecture. I really hope this explainer changed the way you look at the internet and leaves you eager to explore even more about how our digital world is actually wired. Thanks for joining me.